This impressive piece of equipment is known as a CTD?
CTD, close enough. This is a suite of various instruments that oceanographers commonly use to describe mostly the physical parameters of the ocean from the surface down through the water column to the bottom. It's called a CTD, which stands for conductivity, temperature, and depth. Temperature, conductivity, from which salinity is calculated. Depth, of course, so that it knows what depth in the water column it's collecting all of the other parameters. Dissolved oxygen concentration, the amount of light that's coming down from the surface, how turbid the water is at its depth, how muddy or silty, how much phytoplankton is in the water in a relative sense. It measures all of those things twice a second, all the way down to the bottom and all the way back up. And from those measurements we can then produce a graph, a visualization of how dense the water is, how cold it is, how salty it is, potentially how productive it is in terms of phytoplankton, and how much oxygen is in the water column.
How deep can you go with this?
This instrument is rated to go to 600 meters in depth. The deepest part of Glacier Bay is a little over 400 meters, so that's almost a quarter of a mile.
You're just labeling some of the bottles for the station that we're at, so that they're all ready when this comes back up with water in it. Save as much time as we can. This is today's first station, first of the cruise, for this winter cruise, and this will be station number 24.
Well, how many samples are you going to take?
We're going to be taking 5 different types of samples today. So these ones that I'm labeling here are for nutrients. They'll get things like phosphate and silicate. These little ones, little glass ones, are for O18, for oxygen isotopes, and they'll help us kind of identify different water masses. They'll tell us fresh water from the more marine seawater.
And the goal of your project is to measure ocean acidification, is that correct?
Correct.
In Glacier Bay.
Yes, so Glacier Bay has a lot of glaciers, obviously, and that fresh water is low in a thing called alkalinity, which gives seawater its ability to buffer against changes in pH. And so as more fresh water enters the bay, that surface water where that fresh water sits becomes more likely to decrease its pH when it takes up CO2 from the atmosphere. And that in effect affects the little things that live in that upper layer of the water column in which everything else in the bay eats.